operation on the array, that is inserting an element onto the array. That means when we have an existing array, we are trying to insert an element into the array. We are trying to insert an element into the array. So the different possibilities are three possibilities. If you want, you can insert an element at the end of the array, which causes difficulties. Element, how to element? That's what those two initial one 3, 5, 22, 77 are the existing, and this is the scenario when 4 is inserted at the end. It will not make any difference, because after all these elements we are just trying to insert 4, one more element at the end. It doesn't need any shifting of elements. We don't need any shifting of the elements in this case. Whereas if you consider one more scenario, what is that scenario? The element 4 is inserted at index location 2 in this scenario. That means at index location 2, we have inserted element 4. We have inserted the element 4 at this index location 2. That means this has to be shifted to the next location. That means 5 will go to the next location. 22 is coming to the next location. 77 is coming to the next location. And this is where we have inserted. That means either in the beginning, even if we insert in the beginning, all the elements should be shifted to the right side by one location. If you insert somewhere in between, all the elements should be shifted to the right by one location. That is the rearrangement that you have to do while you are trying to shift the elements, while you are trying to insert an element onto the array. That is the scenario. So what is the normal logic as per this algorithm? What is the normal logic here is, I'll just explain the overflow, how actually this algorithm works. Overview of the algorithm. How basically that algorithm is going to function. So assume that you want to insert at this location 0, 1, 2, 3, 4, 5, 6. You want to insert one element at this particular location. You want to insert one element at this particular location. That means at index 3. So already there are some elements. Assume these are the elements 10, 20, 30, 40, 50, 60, and 70 are the elements. And we should have one extra space left out. The array should be declared in that way. Now, if you want to take new element called 80, if you want to insert new element called 80, new element called 80 at the index, what is that index? At the index 3. I think this is where you want to insert. What is the logic here is, start from the last element or start from the last index, whatever is the last index, start from that location. That's why I is being started from n. I is being started from n in this algorithm. Start from last location. So what is the last value for the I? Last value for this I is I. I is 6. Whatever element is present in the last location, take that to next location. This is what you have to repeat. That repetition is being done in this loop. Next, the element present in the 5th location will go to 6th location. The element present in the 4th location will go to 5th location. The element present in the 3rd location will go to 4th location. That is the normal shifting you have to do. The logic here is the normal shifting you have to do. So once we shift all the elements, how the scenario will be? Scenario will be something like this: 20, then 30 is being shifted to next location. 30, 40, 50, 60, and 70. And these are the index values as well: 0, 1, 2, 3, 4. Now at this location we should do, right? 1 second. the assumption was not for this. We were trying to insert that location. Index value 0, 1, 2, 3, 4, 5, 6, 7, 10, 20, 30 will be as it is, and this location becomes free. Why? Because shifting location, we have to go on shifting from right to left, else it will overwrite the elements. We have to go on shifting from right to left, so this will become 40, 50, 60, and 70. So the elements from the specified right by one location. Now all the elements have been shifted. Now once this location becomes, and that is where we insert the element. That is where we insert the element. That is the fundamental logic for inserting an element onto the array. That's how it is working in this program. So how it works here is, we have included the required header files and array is being declared. What is that array? Like array has 10 different locations, and these are the elements which are already present. What is that array here? The array which is already being used here is ARR. This is the array. How many locations are reserved for that array? For that array, 10 locations are reserved. 7, 8, 9, 10. And we know that index value start from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is what is as per this declaration I am writing. As per the declaration, what are the elements stored here? -1, 3, 5, 22, and 77. Just initial value for the array. Array is being declared. This is the impact of the first line. Now these are the normal variables what we use for the execution purpose, k, n, and p, and value of n is equal to 5, because these are presently 5 elements within the array. The contents of the array are, we are just displaying those array values in this one. As it is, they will be displayed like how we discussed just now, the traversal of the array. What it for loop does here is, it will simply display all the elements present in the array. That is -1, 3, 5, 22, 77 will be displayed. Now we are asking user, enter the element to be inserted. Which element you want to insert? Say that will be stored in the variable p. Say assume you want to insert an element called 80. I want to insert an element called 80. Now at which index you want to insert? You want to insert 80, but at which particular index value you want to insert? We are asking here, enter the index location where that 80 has to be inserted, and that is being stored in the location k. What the k contains? Say the index, probably I'll take it as 2. K is 2. At this particular index location, you want to insert that 80. Now what we have to do here is, we have to shift all the elements. K is 2. I'll write here k is 2 and p is 80. K is 2 and p is 80. Right? So after shifting, I will rewrite the array here. After shifting, I will rewrite the array. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 10 locations are there. This is the array after shifting, how it looks like. Now this is where we have to start shifting. So as I said, we have to start from the last element of the array. That is, we are starting from I equal to n. That is, we are starting from I equal to n. What is n? N is 5. So what I will do, I will initialize I to 5. That means we are starting from this location. Is that is greater than or equal to k. 5 is greater than or equal to 2. It is true. 5 is greater than or equal to 2 plus 1. We will get array of. So what is I? I is 5. 5 plus 1 is what? 6. So 5 plus 1 is what? 6. 1 second. 1, 0. array of I is equal to n, I is equal to 5, array of 5 that will be obtained and it will be assigned to I plus 1. 1 second, array of I plus 1 will get array of I is equal to 5. Zero, 1, 2, 3, 4, 5. Here there is a mistake in this text. It should not be I equal to n, it should be I equal to n minus 1. It should be I equal to n minus 1. That note you have to do. There is a mistake in this textbook. It must start from indexing n minus 1. So when n I is initialized to n minus 1, what will be the value of I? I will be 4. Now it works properly. Array of 4 is what? Array of 4 is 77. Take that 77 and place it in the place where array of I plus 1. I plus 1 is what? 5. Array of 5 will get array of 4. Whatever value is present in array of 4, that will be assigned to array of 5. That means at this location 77 is getting shifted. We have to shift every element next by one location. That's it. Only thing is this initialization is wrong here. It must start from n minus 1. Then decrement the value of I minus 1. I will become 3. So 3 is greater than or equal to 2. Condition is true. Next, what I have to do? Take array of I, then assign it to I plus 1. What is array of I? I is 3. Array of 3 is what? 27, 22. 20, array of 3 is what? 22. 22 will go to array of 3 plus 1. 3 plus 1 is 4. So array of 3 plus 1, that is 4. This will get 22. Just shifting to the left. The next index will be assigned with the value present in the present index. That's it. Next, again decrement the value of I becomes 2. So check the condition. I, is it greater than or equal to 2? Yes, it is true. Yes, it is true. Then what I will do? Array of I, take it and assign it to array of I plus 1. What is array of 2? Array of 2 is 5. 5 will be assigned to 2 plus 1. That means it will shift to the next location. It will shift to the next location. Now, if you can see here, the second index is being freed. Why? Because this is the location where we want to insert the new element. This is the location where we want to insert the new element. So the remaining, these two values will be same. They will not get altered. Minus 1 and 3, they will be as it is. Now, after this for loop, what we have done here is, see, when the for loop will terminate, when you again decrement the value of I becomes 1. Check the condition. Is that 1 is greater than or equal to 2? No. Condition fails and will come out of the for loop. And once you come out of the for loop, this is where actually we are inserting the new element. What is the new element? New element is 80. That 80 is being assigned in the place what? Array of k. What is k? K is 2. Array of 2 will get which value? 80. Array of 2 will get which value? 80. We have inserted successfully and the value of n is being incremented. So n becomes n plus 1. Earlier value was of n was 5. That means there were 5 elements. Now n becomes 6. That means there are 6 elements in the new array, and simply in this for loop, what we are doing, we are successfully displaying all the elements of the array. We are successfully displaying all the elements of the array. So very simple logic here is point to the index where you want to insert the elements. From that index, shift all the elements to the right by one location. Go on shifting all the elements to the right by one location. Here, and please note there, here is the mistake. It must start from n minus 1, not from n. So I'll just give the demonstration how actually the shifting will work. 4.2, the second program, right? The same elements are being considered. I'll run the program. Enter the element 2. These are the existing array elements. So I'll take the index as 2. Just know what we have studied. enter the element to, oh, okay, element I would have given 80. Okay, it's okay, element is 2. Enter the index location where you want to insert, that is which one we took here, the explanation part. It was 2 only, yes, 2. Now you can see the difference now. At the second index we have inserted new element called 2. The earlier elements were -1, 3, 5, 22, 7. Now the new elements are -1, 3, 2, 5, 22, 7. We are trying to insert a new element at the specified index. Now I'll take one more index, enter the element to be inserted. 80 is the element. Where you want to insert? Let us insert at the index 3. If you insert at the index 3, what will be the output? Output will be -1, 3, 5, 80, 22, 77. So index is 3. Yes, -1, 3, 5, 80, 22, 77. Because at the index 3 we have inserted 80. We have inserted 80. So that is how the insertion of an element will take place. That is how we can insert an element onto the array. This is what the logic for inserting an element onto the array.